My name is Cassandra. Thank you for joining me today. This is the first, I thought it was day 2, but I am day 1, session 1, and we will be discussing how to think like a programmer. So again, my name is Cassandra. I am with Cisco. I'm a passionate Pythonista here, and I'm really excited to be sharing this with you today. Today's intention is to provide you with the tools and techniques to minimize frustration, your required time to code, and code refactoring, or which means changing your code around. This will allow you to invite opportunities for collaboration and so much more. What will we cover today? A little bit of background about me, why you made a wise decision to be here, what to consider before writing code, what exactly is a bare bones process, additional resources, an example walkthrough of a very simple rock, paper, scissors game, and then of course a recap. So a little bit about me. I graduated from Texas Christian University in 2008 with a Bachelor of Science in Computer Science. Since then, I joined Cisco Call Manager TAC team in 2017. And in 2 years, I was blessed and honored to have a role created for me where I was the collaboration scripting lead. I've trained our TAC collaboration engineers on Python. I started a bi-weekly, what I call coding hour, where each session we share not only training on Python, but other programming languages as well. We've also shared tools, everything that we've been doing within Cisco to help spread the news, things like that. I've also been diving into some data science and machine learning, and so today is more about the thought process of being a programmer. So, why you made a wise decision to be here today? First of all, Python is hot right now in the tech market. It also allows you the ability to automate the boring things. There are tons of benefits to automation, including minimization of human error, opportunities to expand your abilities, minimize time, and maximize your resources. And then, of course, having this thought process allows you to create uniform standards of code and improve readability and code maintenance. So, Kent Beck is the original writer of the Agile Manifesto and creator of the Extreme Programming series. He stated, "I'm not a good programmer. I'm just a good programmer with great habits." So what's the difference between a habit and a skill? A habit is a settled tendency or practice, something that you do over and over until it's just like reading the back of your hand. Skills are your ability to do something well. This could be perhaps excelling at troubleshooting, or it could be excelling at failure. Both are skills. What happens when you learn a new skill or learn something new? There's something called a neuron in your brain that makes new connections. The more you practice, the more you work at that, the stronger that connection becomes, and that's what creates your skill. Tony Robbins, a very big guy in the personal development space, has stated repetition is the mother of skill, and that's why. The more you repeat something, the more you do something, the easier it becomes, and the faster you get at it. So let's talk about bad versus good habits. Bad habits, not cleaning up your code. I get it. We work on code, we have a lot of comments, and we comment things out because we're not sure if it works, or we're working on something new, testing to see if it's better than your old one. But once you create the code that you need, go back and get rid of the code that you no longer use. Don't use it as your notebook for your notes, because this is going to not only make it harder for you to go through, but anyone else who tries to go through your code later. You also, if you're not modular, which means making smaller functions, this is a quote-unquote bad habit, because again, you're not allowing opportunities for collaboration, and you're also not allowing for minimization of your time. Not leaving breadcrumbs. What's a breadcrumb? A breadcrumb is something that if someone comes behind you and tries to know what you did or how you found out how to do it, perhaps you have a URL where you found out how to use that piece of code. So that's what I call breadcrumbs. What are some good habits in programming? Clear, concise code. Sometimes that's not always available, But if you can make it minimized, you can make it efficient, this is what you want to strive for. Comments for additional clarification. Sometimes the code itself should speak for itself. Sometimes it doesn't, and that's why you need commenting. And then, of course, following style and coding guidelines. They're there to help you. So things to consider before writing code. Larry Nevin said, that's the thing about people who think they hate computers. What they really hate is lousy programmers. So let me ask you a question. Have you ever been frustrated that a program didn't quite work to what you felt it needed? For example, a menu that's not alphabetized. Our brains work in such a way that alphabetizing a menu is more beneficial for us because we may not see the words because they're not alphabetized, they're not logically organized. Have you ever had a code crash for no reason, no logging? How frustrating is that for you as a troubleshooter to not know what exactly happened? Where exactly did this crash? And the reason that this is considered lousy programming is because you have to, if you don't have the ability to go back through it, who does? Things you want to consider. Who is your target audience? What is it that they're wanting to actually accomplish? And then, of course, how will their experience be affected by your code? It's all about the customer experience, whether it's your end user or your business unit. If you don't do what they need, then you haven't really accomplished what you set out to do either. Martin Fowler, any fool can write code that a computer can understand, but good programmers write code that humans can understand. So one other thing to think about, what are your required timeframes and your milestones? How can you break it down in order to invite opportunities for collaboration? Who's going to come behind you? The people that are going to fix any problems with your code or maybe even expand upon it. How do we make it future-proof? What do I mean by future-proof? Future-proof is your ability to think ahead. How is my end user going to break my code? How would it be possible for someone to inject something into my code? How can I stop that from happening? Or, if you have nice-to-haves, right, you have your required needs of your business unit and your nice-to-haves. If your nice-to-haves aren't required immediately, what can you do to position your code in order to have that easily be implemented later on down the line? How to make your code minimalistic. Again, if you have a long code line, it's very difficult to read through. It's sometimes even difficult to troubleshoot with. So why a bare bones process? Think about it this way. When you're building a house, you start with a blueprint. You can't just start with plumbing or electricity because you don't know where everything goes. But if you start with a blueprint and grow from there, you're building your foundation and making it easy for you to build upon. If you don't have this process, this outline, you could potentially lead to the death of your project by missed deadlines. Other benefits are easier troubleshooting, collaboration opportunities, and the rest that you see on the slide. I'm sure you could probably think of more. The most important thing above all is your ability for your program to accomplish the needs of its users. So what exactly is the bare bones process? First step, gathering your requirements. Edward V. Berard once said, walking on water and developing software are easy if you're frozen. Now, I'm sure many of you have been in the position where you've been told, I need X, Y, and Z done by this date. And then 3 weeks later, they said, oh, wait, we don't really need that anymore, we need this. So if you have the ability to be flexible with your code, that is what's really important because there are going to be times where your business unit will make those changes. So again, what is the overall intention of the business unit? What are they wanting to accomplish? What are their time constraints? This is what's going to be most important for you to realize, okay, we have this list of nice-to-haves, but let's prioritize what's needed right now. Immediate interval deliverables. This comes from the Agile methodology and allows you to create more upfront so that you get your programming done in a much faster way. Need versus nice to have. If it's a nice to have and you miss out on the needs, then you're going to be pushing back your timelines and causing problems not only for yourself, but for the business unit who asks for your help. Additional resources required. Do you need additional programs installed? Do you need to know what API? Is it even available, or do you have to create it? Those are things you need to think about before you write any code. Is this part of something bigger? Is this just a big cog in the big program of whatever it is that you're doing? For example, at Cisco, I've written several programs that had to have steps. The very first one that I wrote for Cisco was a case management tool that pulled information from our ticketing systems API, and I had to do it in steps. The big picture was to create one that our managers could see the backlog of our engineers visually. But in order to have it for the team, you had to have it for the individual, and that was the first step. How often? Yes.
Are you going to chair the presentation?
Pardon?
Are you going to chair the presentation?
Yes. Yes. How often will you meet with your programmers, with your BU? It's possible that you may only need to meet with your BU once a week, every 2 weeks. What's most important is that you meet with whoever's working on that project much more frequently. For example, one of the best practices for Agile is actually meeting with your programmers daily for about a 10-minute stand-up. What happens during that stand-up? Each person talks about what they did yesterday, what they're going to do today, and any roadblocks that they may have. That way, everyone knows what everyone else is doing. They can step in and go, oh, hey, you said you were doing this. I've done this. Maybe this can help you. It allows you to have a lot more collaboration. Again, everything you do should be focused on what the user experience is going to be like. So we talked about gathering your requirements. Step 2, determining all required functions. So how do you determine your required functions? Think about what can be reused later by other programs. Again, you want to minimize the required time to code, minimize the number of times you write code. And so you want to think about what can be reused by other programs, as well as what's reused by your specific program. Again, you want to be as Pythonic as possible. This is going to be about 15 lines per code, but this isn't always something that you can attain. It's something you want to strive for, but may not necessarily be something you can do at this point. Again, create space for your nice-to-haves. You want to make it easier for yourself to implement those future opportunities that the BU might want for your program. And then, of course, think each section through. If you just start coding, you might think that you need to have this, or you might need to do that, or pull in information from an API. Anything else? It's nice to have. So we talked about gathering requirements and determining what's required for those functions. The next step is to actually create the bare bones infrastructure. Part 1 is creating your function outlines. And I'll show you those examples here in a moment. Part 2, tying those functions into your main. So when the program actually runs with Python, there's a specific section that occurs that it tells it, hey, this is running as the script. Here's the stuff that we need to do, versus actually being something you can call on the functions later. And then part 3, testing your logic, making sure it's moving between those empty functions the way that you expect it to. And then finally, once you have the outline done, this is when you can assign the functions to your team, which will allow you to minimize your time to complete the project. Additional resources for you. First one, Pilot. This will allow you to ensure standardization of code analysis. So coding standards, it looks for programming errors, and it allows you to actually extend it to fit your specific needs for coding standards. PyTest allows you to create tests for your programs. So I'm sure you all have had frustrating times where, for example, maybe there was an update to a program that you had, and maybe you had to upgrade. And during that upgrade, it was a failure. Well, that's a bug. So if you didn't test for that, what happens? People get frustrated, they get upset. And then finally, This link right here is to a public section on my GitHub that will include all of the code that I'm sharing with you in this presentation. I don't have a link for this PowerPoint right now, but I will be sure to get it out to you. This is what that link will look like. As of November 28th, we have the README, which explains what it is, the step 1, which is the BU requirements for this particular program, step 2, which is the base functions we talked about. I'm sorry, the notes of the base functions. Step 3 is the actual functions that outline. Step 4 is tying them together. And then this is the one that you can actually run on your computer to see what it looks like. So let's talk about this rock, paper, scissors game. Step 1, requirements. The BU has come to you and said, we want you to create a program for the kids that come to visit their parents to keep them busy. But they want it done in a month. So what are the requirements or features for the script? At least one player, one computer, some number of combinations, and a way to tell who won. Anything else? It's nice to have. These are some examples of nice to haves. Perhaps you have more options, such as lizard or spot, right? And the list could go on. Step 2, determining all required functions. Again, it's outlined here. It's also on my GitHub for you. Step 3, create function outlines. You have your function line at the top, your documentation string, which will tell you what goes in, what it does, what goes out. Any logging to let you know when you're troubleshooting that you went into this function, you came out of this function, and then anything that it returns. Step 4, tying them all into your main. So here again, I have the outline, documentation string, what goes in, what goes out. Commenting for someone who may not know exactly what's going on, and then of course I'm calling each of those functions. If you didn't notice in the last slide, because I did bring to your attention, documentation string actually said step 3 when it was on step 4. So something you want to consider when you're coding is to make sure that anytime you make a change, that you go back to the documentation string and make sure that it's complete and valid to what you've actually changed. It is so frustrating for yourself and for other people. If you're coding 6 months down the line and you go, wait a minute, this isn't right. This doesn't match up with what I'm seeing here. So it's really important to make sure that you update that documentation as you code. Step 5, test it. What you see here, the white one is actually logging the file. The black one is logging the CLI. Inside the code on my GitHub, you'll see exactly how to do that. The ones in white are the formatting. The arrows in orange are the logging levels. The one at the top is logging the file. The one at the bottom is logging to your CLI. So you can have different logging coming out between what's on your file and what's on the CLI. What we covered today. A little bit of background about me, why you made a wise decision to be here, what to consider before writing any code, what exactly is a bare bones process, additional resources, and an example walkthrough. Thank you so much for being here today. My name is Cassandra, and I'm a passionate Pythonista at Cisco. This was How to Think Like a Programmer speech. And if you have any questions, please feel free to contact me with any of these available means. That's my Cisco email, my GitHub username, and my LinkedIn account. And then, of course, the link to the actual GitHub repository. Any questions?
Thank you, Cassandra.